Welcome back. This is section 5.3, which is on radicals. We're going to start this discussion by talking about square roots. So, a square root of a number, let's call that number x, right? The square root of x is a number, let's call it s for the square root, such that s squared equals x, right? And it may be weird to look at it this way, but there is such a number that if I square it, I get x, and therefore s is the square root of x, right? That is to say, something like 3 is the square root of 9, because if I square 3, I get 9, right? So that's what it means to be the square root. It means if you were to square that number, you get the other number, right? And so I can look at this as this statement that I just wrote here, 3 is the square root of 9. Because if I take 3 and square it, I get 9, but negative 3 is also a square root of 9. Because if I square negative 3, remember I'm squaring negative 3, meaning negative 3 times negative 3, that's also positive 9. Right? And so I have two square roots, right? So if you're asked, what are the square roots of 16? Some number that when multiplied by itself will give you 16. It could be 4 or it could be negative 4. Right? 4 squared is 4 times 4, which is 16. Negative 4 squared would be negative 4 times negative 4, which is positive 16. There's two possible solutions here, right? In math, we don't like ambiguity. We don't like that there's two possible ways to express this. And therefore, the mathematical symbol for the square root actually means the principal square root. The principal square root is the positive one. Now we indicate that with the radical symbol. This symbol is called the radical, right? And it means the principal square root. Or the principal root. Sometimes it's not a square root. We'll talk about cube roots and higher degree roots. But that's what it means, is the principal, it means that positive root, right? Okay. So let's take a look at using that. That symbol, square root 16, this means 4, right? If I want the other root, I simply indicate that by putting a negative in front of the principal root, and therefore now I have negative 4, right? So also say 36, the square root of 36, the principal square root of 36 is 6, whereas the negative square root of 36 is the negative 6, right? And we have usage for that symbol. It's worth knowing the first couple of integers and their squares. So it's worth knowing that 1 squared is 1, that 2 squared is 4, and so on, right? Maybe up to 10. 10 squared is 100. Because knowing these squares gives you the square roots. The square root of 100 is 10, the square root of 4 is 2, the square root of 1 is 1. You should know this, 0 squared is 0, you can square root 0, right? So it's worth taking a moment to at least memorize those. You can go beyond. 11 squared is 121, 12 squared is 144, 13 squared is 169, so on, so on, so on. Alright, we have a couple of properties of square roots. The first one is the root property of fractions. So for example, if I have something like, say, 9/16 as a square root, right? I can note that the multiplication here is, if I take 3 over 4 and I multiply it by 3 over 4, I'm multiplying the numerator and multiplying the denominator. That gives me 9 over 16. But this is to say that I had 3 over 4 squared was 9 over 16. And because this square, right, back when we talked about exponents, 3 4 squared is the same as 3 squared 4 squared, this square root kind of distributes similarly. And so I can treat this like the square root of 9 over the square root of 16, and I can take the square roots individually, so that gives me 3 over 4. And so the property written out is this. It says the square root of some fraction a over b is equal to the square root of a divided by the square root of b. I can break it up into the square root of the fractions. So if I have something like, say, the square root of 25 over 81, I can treat this like the square root of 25 divided by the square root of 81. The square root of 25 is 5, the square root of 81 is 9, and I'm done. I have simplified it. So that's actually pretty helpful when I have to take square roots of something like 0.64. Because I can write 0.64 as a fraction. (64 over 100). I don't want to simplify this. And the reason I don't want to simplify this is because I can break this up now into the square root of 64, which I know, and the square root of 100. The square root of 64 is 8. The square root of 100 is 10. And then I can simplify this. 8 over 10 is the same as 4 over 5. And therefore the square root of 0.64 is 4/5. If I want to answer this as a decimal, I can actually backtrack to 8/10. I can rewrite this as a decimal because it's just 0.8. And I can verify that. 0.8 multiplied by 0.8 is going to give me 0.64. Now that's not to say that this method will work with every decimal. This one just happens to work because it's over 100 and that's a nice value. It also happens to have had a 64, which is a nice value. And so if I take a look at perhaps, say 0.064, right? And you look at that and say, oh, 64 again, there's going to be an 8 in here. But if I try to take the square root of this and I do the same method, I would have to write this as 64 over 1,000 instead of 100. I can break this up into the square root of 64 and the square root of 1,000, and it looks great so far. The square root of 64 is 8, but the square root of 1,000 is not great, right? If you have a calculator, throw it in there. The square root of 1,000 is not a nice number. It's an irrational number, and You get this 8 divided by 30 something, I can't remember what it is, but it's never-ending decimal, and it's ugly, right? And you can't really simplify this down to a nice whole number, and so this is not particularly helpful. Right? So what do? Well, sometimes we can estimate, right? We have a lot of numbers that when you try to square root them, you end up getting an irrational number, right? So let's say I have this 10 and I want to know where about on my number line the square root of 10 is. Right. So we'll make some observations. 10 I know is greater than 9. And 9, I chose 9 specifically because I know the square root of 9. The next number after 10 I know the square root of is 16. And so it's worth noting that 10 is between 9 and 16, and all of the square roots are going to maintain these inequalities. So if I square root this, the square root of 9 is 3. Square root of 10 is the square root of 10. And then the square root of 16 is 4. So I don't have a great grasp of precision here, but I do know that the square root of 10 is between 3 and 4, and that helps me at least with a ballpark figure. How about the square root of, let's say, I don't know, 35? I don't know. I do know, though, that 35 is less than 36, chosen specifically because the square root of 36 is 6. The next one down here would be a 5, of course, because 35 I know is between 25 and 36, and therefore the square root of 35 is somewhere between 5.6. And so, again, I don't know a whole lot, but I do know that the square root of 35 is 5 point something, right? Since it's so much closer to 36, it's probably closer to 6 than it is to 5. But for now, that's a good start. If you need this to any degree of accuracy, you can throw it into a calculator, right? There are methods to find square roots. We're not going to discuss them here. Most people would actually be able to take the square root of 35 after they've taken calculus. There's a pretty good way of linear approximations, but that's, far down the line. For now, we have calculators. We can throw it in there if we need that, right? All right. Let's look at the cube root of something. Let's say the cube root of some number x is a number, let's call it n, such that n cubed is x, right? Now we would indicate that we want to find the cube root by the same symbol, and let's say we want to find the cube root of 27, but there's going to be a little number up here, right? This little number right here is called the index. Right? The symbol is, of course, the radical, sorry. And the number in here, this number is called the radicand. In math, there's a lot of terms. Like if you go back and look at addition, the two things that you're adding are called the addends. If you're subtracting a number, one is called the subtrahend. All these weird words. They're not terribly important as much as knowing how to use them, I think. But the radical now has this little index. If there's an index there, it means that it's a cube root now instead of a square root. Right? Which means that I would have to have something 3 multiplied by itself 3 times to get that number. So for example, 27, if I want to find the cube root of 27, that is 3 because 3 to the third is 27. Right? So for example here, the cube root of 64. Well, I happen to know that 4 times 4 is 16, and then times one more 4 is going to give me 64, and therefore I have 4. Right? Now I just happen to know that, but if you don't know that, you can actually factor this down. 64 is divisible by 2. If I divide 64 by 2, I'm left with 32. And anytime that I get a prime, I'm going to circle it and then break down the other number or anything that isn't a prime. 32 is divisible by 2, circle that prime. When I divide 32 by 2, I get 16, which is divisible by 2, giving me 8, which is also divisible by 2. And I'm just going to yank a whole bunch of 2's out of this thing. There they are. Right? And you'll notice here that this 3 is how many factors I need down here, right? But I have 1, 2, 3, so there's one group of 2's. And there's 1, 2, 3, my second group of 2's. So how many is that? Well, there's 2 groups of 3, and so I have 2 groups of 3 2's. Therefore, I have 2 squared, and that's my 4. Right? You can think of this as I need 3 to pull out, so I have 3 2's that come out as a 2. I have 3 more 2's that come out and multiply by the 2 that's already out there, and that's how I get my 4. Okay? Let's take a look at another one of these. Let's do 216. Okay. If I'm looking for the cube root of 216, I don't know what that is off the top of my head, right? But I can factor this, because 216 is divisible by 2. So if I divide it by 2, I get 108. 2 is a prime, so I'll circle it. 108 is still divisible by 2, so I'm going to just divide as many 2's out until I can't, and then move on to 3's and then 5's and so on. Dividing 108 by 2 gives me 54, which I can take another 2 out of, and that gives me 27. There's no more 2's in here, so I'm going to start on 3's. 27 is divisible by 3, leaving me with 9. Divisible by 3 again, leaving me with 3, and that's it. That's as far as I can go. I just have primes. And so I need 3. I have a group of 3. That's a 2. Right? There's 3 2's, so 1 2 comes out. And there's 3 3's, so 1 3 comes out. Right? This is how many of the group I need in order to pull one of them out. I have 2 times 3 on the outside, that's 6. And I can verify that 6 times 6 times 6 does indeed end up being 216. And so I have the cube root of 216 is simply 6. This, of course, isn't limited to cube roots. I could take, say, the 4th root of, say, 16, right? Now this 4 up here means that I need to have 4 factors of the same thing before I can pull it out as 1 on the outside. So 16 is divisible by 2, leaving me with 8. 8 is divisible by 2, leaving me with 4, which is divisible by 2, leaving me with 2. There's 4 factors of 2, and therefore I have 2, because now this is 2 to the 4th equals 16, so the 4th root of 16 is 2. We can also play with negatives, right? If I have the square root of, let's say, negative 4, can I work with this, right? Is there a possible solution here? And we'll show that there isn't, because for this to have a solution, that means I would have to have some number, whatever that number is, if I square it, that gives me -4. And I think you can see if you square any real number, you're not going to get a negative, right? Let's suppose a is some positive number. If I square it, it's still positive. But if a is negative and I square it, a negative number squared is still positive, and so there are no solutions to the square root of a negative number in the real number line, right? But if I am looking for the cube root of, say, -27, is there a number that will work here? And the answer is now yes, because I have an odd parity up here. I have an odd index, right? And so -3, if I note that -3 multiplied by -3 multiplied by -3, negative times negative times negative is negative, so I'm okay here. -3 times -3 is a +9, multiply that by -3 and I get -27. And therefore, if I have an odd index, a 3, a 5, a 7, and so on, I'm okay to have a negative radicand, right? And so I can end up with a negative solution here. Good. All right. If I have variables under there, let's say I have the square root of x to the 10th, right? I can think of x to the 10th as x squared times x squared times x, 3, 4, 5 of them, right? And therefore I can think of this as simply the square root of x squared as an x. I can take out another x, I can take out another x. And so I'm really taking out 5 x's here, and so this ends up being x to the 5th, right? The index here is 2, so it's like I took that 10 and divided by 2 to give me x to the 5th, right? And I can think of it that way, and therefore if I have, say, let's not write it that way. We're not ready for that. Well, let's look at one more of these though. Let's say I have x to the 8th, y to the 4th, and z squared, right? Now again, this square root means that I have to have pairs, right? And so there's 4 pairs of x's, there's 2 pairs of y's, and there's 1 pair of z's, right? And I got that by simply taking 8, dividing it by how many I need to make a group, a pair, 2. 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. And so I can simply call it that. There's 4 pairs of x's, 2 pairs of y's, and 1 pair of z's. And I've just taken the square root. It doesn't always work out nice and perfect like this. Let's say I have the square root of x to the 4th, y to the 5th, and z to the 6th, right? I can see that I have 2 pairs of x's, but I have 2 pairs of y's and 1 left over, right? Because there's 5. There's a y times y times y times y times that last y hanging out there. I have 2 pairs, so I have 2 pairs that come out, but this last one, this oddball, has to stay under the square root. It can't come out. And so when I'm done writing this, I am going to still have a square root and a y that's stuck in there that can't come out. I can't simplify. With my z's though, I can see I have 3 pairs of z's. And so I have that. X squared, y squared, z to the 3rd, and a square root of y that's left over. Now, of course, this is the same with cube roots and 4th roots and 5th roots and so on and so on. If I have the cube root of x to the 9th, y to the 12th, right? Now I'm looking for triples. 9 is 3 triples, and so this is x to the 3rd. 12 is 4 triples, and so this is y to the 4th. Right? And again, it might not always work out beautifully and nicely. If I had a z to the 20th, right? If it were to the 21, there would be 7, right? But it's not, and so I have to take the 18 of these that do make triples, right? 18 of these z's will make 6 triples, and so I have the 6 that can come out. But if I've taken 18 of them, there's 2 left over, and so under this cube root, I still have to write the z to the squared, the 2 guys that couldn't form a group enough to pull out of the radical. Good. All right, let's take a look at one more example here. We might be asked to simplify something like, say, the cube root of -8 x to the 5th, y to the 6th, z to the 25th. Right? So I'm going to take the cube root of every single one of these. Negative means that my answer is going to be negative. The cube root of 8 is 2, because 2 times 2 times 2 is 8. There's one group of 3 x's, and I'm going to have some stuff left over. That is, 2 of my x's are left over. There's 2 groups of y's, and that goes nice and evenly. And then 25 is not divisible by 3, but 24 is 8 times 3, right? And so I have z to the 8. There were 8 groups of 3, but I took 24 of them to make that, so there's 1 left over, and so I have a z, right? Under the cube root still. All right, good. Okay, let's do one last one of these. Let's say I want to take the 5th root of 96 x to the 20, y to the 23, z to the 16. Now again, I'm looking for groups of 5 to pull out. 96, that's kind of a difficult one. Actually, I'm going to do that last, because I can do x easily. X to the 20th is 4 groups of x. Or excuse me, 4 groups of 5. And so I have x to the 4th that pulls out, and no x's left. 23 is also 4 groups of 5. With 3 left over, right? And then z to the, 16 is 3 groups of 5 with 1 left over, right? And I kind of got, maybe a little too excited to write this root, because there might be a number left over from my 96 that has to go in here, but I'll fix that when I get to it. So 96, I need to know what the factors of that are. So I've got 96, I can divide 2, so 96 divided by 2 is 48. Divided by another 2 is going to be 24. Divided by another 2 gives me 12. Divided by another 2 gives me 6, which gives me 2 and 3. Right? Now I need 5. Right? So I have 1, 2, 3, 4, 5 2s, so I can actually pull my 2 out. But this 3 is not in a group of 5. My camera doesn't even... How far does this thing go? Alright, my bad, I apologize. Let me scooch this down just a wee bit. Yeah, there. Alright. So I've got my 5 groups of 2, but this 3 is left over, so the 2 can come out. Right, but I'm going to have a 3 left over, and so that 3 also has to stay inside of the 5th root. Right? And that's my simplified version. This 2x to the 4th, y to the 4th, z to the 3rd, and then the 5th root of 3y to the 3rd, z. All right, thank you, and I will see you guys for the next section.